Lesson 19, our first derivative standard today. Accomplishing the definition of derivative is our big thing. So if you'll notice, the title is Derivatives and Slopes of Curves on a Graphing Calculator. So, okay, big thing. You gotta know this definition, or the meaning of derivative, I should say. The derivative of a function at a point is the slope of the tangent line. When we talk derivative, you need to understand that derivative equivalates to slope. When you're asked to do something about slope in calculus, they're usually saying take the derivative. That's usually what that is code for. Okay, so the derivative of a function at a point is the slope of the tangent line to the function at that given point. Okay? So derivative of a function at a point is the slope of the tangent line. Obviously, when we talk about a function other than a line, there's not just one slope, is there? Okay? But the equation of the derivative can represent that slope, and you just have to plug the values in. Okay? So, we know the derivative is slope of the tangent line. And then, this piece probably seems familiar.
Just a little bit.
Okay.
There wasn't one of those in homework last night.
And really, even you mentioned last night, but there's been some of these in homework for quite a while, haven't there? Okay. So, we've started off with the basics and it just keeps going. But, okay, definition of a derivative. I'll be honest. Most times when you go to find derivatives later on in calculus, you're not going to use the definition. But there are times that, for various reasons, the definition is there. You need to recognize, oh, that's definition of derivative. I can take the derivative using my shortcut, whatever the case is. So, this little mark here, we usually read f prime. Okay, f prime of x. This little mark indicates derivative. So, this is saying, okay, the derivative of f of x is the limit as delta x approaches 0 of f of x plus delta x minus f of x all over delta x. Now, we sometimes have seen this done with h's, and I don't think it's in this lesson, but there is at some point, I think today we just use the annoying delta x's. There is at some point where they will officially introduce, okay, you can use h's or delta x's. Okay, so they're the same idea. But it's the limit as delta x approaches 0. And we did one like this yesterday, except with h's, I believe. Now, other notation for derivative. Probably most common is f prime of x. Other common ways to write derivatives, d over d of x. So this is a derivative with respect to x being the variable in the problem. Capital D of sub x like that. You don't usually see that one, but we need to be familiar that indicates derivative. You never know what they'll throw at you on AP. dy over dx is very common derivative notation. The derivative of the y equation with respect to x. So it's a derivative of y with respect to x. And then d of x sub xy, another one. Okay, so to me, the first, second, and fourth are the most popular ones. Those are the ones you usually see me use for the most part. Okay, example 1. Let y equal x squared. Find dy dx. They make it sound so easy, right? Now, y is another name for what? F of x, right? So this is really saying that f of x equals x squared. And when they ask us to find dy dx, what are they asking us to find? Yeah. They're asking us to find derivative. They're asking us to find f prime of x, if you will. So, we're going to use that big old fun derivative. Okay? Now, so I'm going to start off by saying dy dx equals, because they told us to find dy dx. I try to respect whatever they have us use there. I'm always going to write the word limit, and this is the limit as delta x approaches 0. I will always carry the word limit throughout the problem. I will tell you the sure way to miss at least 1 point on a test is to never use the word limit with definition of derivative. If you never write limit at all in the entire problem, I'm going to take off a point because you have to indicate it's a limit. Okay? So, now, we're going to do the fraction. Officially, it is f of x plus delta x. So, okay, side note, f of x is what in this problem? X squared. So if we're doing f of x plus delta x, what's happening here? X is getting replaced with x plus delta x. So this was x raised to the power of 2. So what am I going to do now?
It's x plus delta x.
X plus delta x raised to the power of 2. So since it was whatever the question is squared, now it becomes x plus delta x squared. Are we okay with that? Because if you don't get that, the problem just fell apart from step 1, right? So we've got to work on that. Okay, so I'm going to write this out as x plus delta x, quantity squared. Then it says minus f of x. What do I put for minus f of x? Minus x squared, just the basic function, right? All over delta x. Okay, equals the limit as delta x approaches 0 of, what am I doing with x plus delta x squared? Foiling? Can you guys foil that in your head? X times x is x squared. We have x times delta x and another x times delta x, which is 2x delta x. Delta x times delta x? Delta x squared, which officially I'm going to put parentheses around delta x. And don't forget, that was just doing the squaring part, right? What else do we still have? Minus x squared all over delta x. There's probably something like this happening about every time. And that is, there's usually going to be something canceled. Okay. Honestly, I almost hesitate to say this. Usually whatever cancels does not have the delta x in it. The delta x terms are still going to be there to some extent. Okay, so the limit as delta x approaches 0. What do you notice about the two terms that are left on top? Yeah, I did something similar to this yesterday, didn't I? So I'm going to factor out a delta x on top. If I factor out delta x, I'm left with 2x plus delta x all over delta x. And the purpose of doing that? Now I have a delta x as a factor on top and a delta x on bottom that cancels. So now I have the limit as delta x approaches 0 of 2x plus delta x. And how do we actually find the limit? If it's the limit as delta x approaches 0, you put in 0 for delta x. So I'm actually taking the limit. So this is where I don't have to write the word limit on my next step. Because once I plug 0 in, I'm taking the limit. And so it's 2x plus 0. And 2x plus 0 is 2x. It's not. I mean, I promise it does get better as you practice this. It really does. It would be a lot worse today if the book hadn't been preparing you for this ahead of time a little bit. I'll be honest. Okay, you ready for example 2? Given f of x equals x squared, find the slope of the line tangent to the graph of f at x equals 4. Any thoughts? Note that phrase.
Yeah, so if the derivative is 2x, and if x equals 4, would it just be 8, or is that getting too easy?
It is that easy. Okay, so first of all, big thing to note here, slope of the line tangent. They're saying find the derivative. And they're saying find the derivative of f at x equals 4. Now, if you're smart about this, how did Ross already know the derivative was 2x? It's the same stinking problem from before, right? So based on what we learned up above, if f of x is x squared, then f prime of x, if you will, is 2x. And that's just me stealing my answer from above. If f prime of x is 2x, they want to know the graph of f at x equals 4. So yes, you are finding f prime of 4. And f prime of 4 means plug in 4. Every place you see x, it becomes 4. And 2 times 4 is 8. So on this parabola, this x squared, when x equals 4, the slope of the tangent line is 8. Which should make sense if you think about it, because by the time you get to x equals 4, your parabola is getting pretty steep, isn't it? Because what, that'd be at 4, 16, so. Okay. Continuing along. Example 3. Let y equals 4x. Find dx of y. Any thoughts about this problem?
Like the same thing we did in 1, right?
We're finding the derivative, yes. Now, what if I say, and we're still going to do the definition of derivative, but what if I say you already know the answer without doing the work? But it is true. You do know the answer. What are they asking me to find? Derivative. And what physically is a derivative? The slope of the tangent line. This is a line, yes? What do you know about this line? Its slope is always 4, no matter what point you're at. So what's the derivative going to be? 4. Now, yes, we're still going to work it out because I want us practicing that, right? But do you see the connection I'm trying to get you guys to make? You know, I need you, like, that has to just be automatic. Derivative, slope. Slope, derivative. Like, that connection just has to be there. Okay? Officially, slope of the tangent line. But based on the fact that you guys know y equals 4x, then you know that the slope is 4. If the slope is 4, then that means the derivative is 4. Now, because I am that way, yes, we are going to prove it, that the derivative is 4. I know. You guys were kind of hoping I'd let you off the hook in a way, but We've got to practice it, guys. Today is the day. So, what am I going to write first when I find this derivative?
dxy.
Okay, so dxy. He's only thinking about the points here. And I mean, AP is going to be the same way. They're going to expect to see the limit. And that's one of those things is when we start looking at AP questions eventually and stuff, I can show you scoring guides from previous test questions. And, there can be, it can say, okay, this was 4 points. One of those 4 points was for writing limit. That's not just a me thing. That can be an AP thing as well. So, okay, the limit as delta x approaches 0 of, okay, it's f of x plus h. What are we doing here?
So we're taking 4x and substituting x for x plus delta x.
Okay, so it was 4 times x. Instead, now it's going to be 4 times x plus delta x. Minus f of x just means minus 4x all over delta x. The limit as delta x approaches 0. What are we doing on top? Distributing 4x plus 4 delta x minus 4x over delta x. Four x's cancel. The limit as delta x approaches 0 of 4 delta x over delta x. Delta x's cancel. The limit as delta x approaches 0 of 4. What happens when we plug 0 in for delta x? There's no place to plug delta 0 in, so the limit is just 4. Surprise, surprise, right? The derivative of this line was 4. Or excuse me, the slope of the line was 4. The derivative is 4. Okay. Example 4. Use the definition of the derivative to show that the derivative of the constant function f of x equals c is 0. What do we mean the constant function? What's that look like as a graph? F of x equals c. It's a straight line, specifically a horizontal line, right? C could be any number. So this could be f of x equals 5, f of x equals 10, f of x equals -8, right? But so we already know in our minds, it would make sense then that the derivative is 0 because the slope of a horizontal line is 0. Now, let's just put that through definition of derivative to show it. So, we're trying to find f prime of x. And I always label that I'm finding the derivative, so I don't have just this random equation on my paper, and I know it's a derivative. F prime of x equals the limit as delta x approaches 0, f of x plus delta x. Huh?
So it's f of x plus delta x, and f of x is equal to c.
Yeah, the is 0 goes with the original. We're not saying f of x equals c is 0. That's just saying the definition is going to be 0.
So it would be c times x plus
Well, this is c, right? Is there an x?
No.
No. Because the rule is, remember up there, every place we saw an x, we replace it with x plus delta x. There is no x here, though. So f of x plus delta x, there's no place to put in x plus delta x, so it's just still going to be c. Because there's no place to sub in, there's no x, so there's no place to sub in anything for x. So like if I said, I don't have you guys sold, I'm trying to, okay, so f of x equals c, right? So what if I say, what's f of 5? Well, is there an x here? I mean, if you want an x, here's what it is. It's plus a 0x if you want. And so this is c plus 0 times 5, which just works out to be c. Okay? Because there is no x in the equation, the result is always going to be c, no matter what you plug in. Okay? There's someone sneaking in my room. I was like, did I just hear my door open? What did I just hear?
I keep forgetting to give these to you from our department meeting. I need to be before tonight because I'm going to say, oh, I gave these to the department heads. you weren't here, so I'm giving it to you today. So,
Hey, thanks. Nothing like last minute.
It's just our standards that are on the SAT.
Okay.
So, which we have juniors, which will be juniors take the SAT this year.
Yeah.
So.
And Summer and I have talked about these,
Yeah.
so
Yep, there you go.
though we haven't talked about the quantitative reasoning ones, but
Yep,
we've talked about.
Just say your department has them.
Okay.
So, all right, thanks.
Thanks. Okay. Are you guys there with me then? Kind of. I'm not convinced you guys like it, but it's easy, I promise. Okay. So this is f of x plus delta x.
So then you just
Minus, what's f of x? That's the easy one. You guys got that. C all over
delta x. So
delta x.
0 over delta x.
Right. So the limit as delta x approaches 0 is 0 over delta x, which officially, if you go one more step, 0 over anything is 0. And so the limit as delta x approaches 0 of 0 is 0. There's a lot of zeros in that problem. Okay. Example 5. Okay. I feel like we had one like this in homework at one point or something. I don't know. This is the not fun one, right? Because there's a fraction now. Okay. Let y equal 1 over x. Find dy dx. So, what do I start off with? The limit is delta x approaches 0 of, okay, it's f of x plus delta x. What is our function? 1 over x. So every place I see in x, we're replacing it with x plus delta x. So what is f of x plus delta x? 1 over x plus delta x. Minus f of x, which is 1 over x. All over delta x. This is where we have to do some hardcore math, right? Because if you put in 0 right now, you get 0 over 0, and we can't do that. Okay, we don't have a way to deal with 0 over 0 at this point in our lives. So, on top we have a fraction minus a fraction. I would say get a common denominator and put them together as one fraction. what would be a common denominator between x plus delta x and x? Yeah, it's x times x plus delta x. So, okay, the limit as delta x approaches 0. And I know that my common denominator is going to be x times x plus delta x. Now, as I look at my first fraction is 1 over x plus delta x. What part of the common denominator are we missing? X. So what do I have to do? Officially, I'm going to say multiply by x, right? And x times 1 is going to be x. What am I missing on my second fraction? We have x. We're missing what part of the denominator? X plus delta x. If we multiply the denominator there, multiplying the numerator of x plus delta x. That's sloppy, sorry. And so, notice, what are we doing here? This is a subtracting. So we're subtracting 1 times x plus delta x. Yeah, I was just debating. So it's x minus delta x, if you will. I just realized you guys, I wrote something up there. You can't even see it. All I was doing is write minus 1 times x plus delta x all over the denominators multiplied. That works, okay? And of course, I don't have it written there, but this is all over delta x, right? If you haven't already cleaned it up, can we clean up the very top numerator there? It's the limit as delta x approaches 0. And x minus delta x is going to be negative delta x over x times x plus delta x all over delta x. You gotta holler at me if I'm off the screen.
I feel bad.
Hold on, say something nicely.
I got you.
Abby's not the type of person to holler at me. Okay, say something nicely.
Okay.
Okay, what do you see here? Fraction divided by a fraction? Yep. You guys see what he's talking about? A fraction? Well, I said fraction divided by a fraction. It's fraction divided by delta x, which, if you want to make it a fraction, that's delta x over 1. So multiply by the reciprocal, keep change flip. So the limit as delta x approaches 0. I'm off the screen. I need to quit trying to zoom in. So I'm going to keep the top fraction. Negative delta x over x times x plus delta x. Instead of dividing by delta x, we're going to multiply by 1 over delta x. What kind of things happen? Get a delta x cancel, right? So I have negative 1 over x times x plus delta x. And now, what do?
Do we just plug in 0 or do we distribute?
Nope. Well, either or. You can distribute if you want to, but you don't need to. If you go ahead and distribute and then plug in the 0, or plug in the 0 and just do the math, we're going to have Negative 1 over x squared.
So when do you know how many steps you need to take before you can plug in?
Well, anytime you have delta x on top and bottom to the point you're going to get 0 over 0, you know you can't plug in anything yet. Okay? Eventually we'll have something called L'Hopital's rule, where we'll have a way to deal with if it's 0 over 0. But right now, as learning definition of derivative, we don't have that. Okay? So, yeah. If you're going to plug in, you're not going to get a valid answer. Okay? And that's where, Ross said, okay, can I just distribute? Or can I just plug in, or do I have to distribute? Either or. They're going to get you there. Okay? Okay. Tell me what to do on number 6. Find the slope of the tangent line that can be drawn to the graph of f of x equals 1 over x at x equals 2. And slope of the tangent line is another way of saying derivative. So f of x was given as 1 over x. What did we find? F prime of x is negative 1 over x squared. So what's f prime of 2? Negative 1 over 2 squared, which is negative 1/4. You guys brought your calculators today, right? We get a math trick on the calculator today.
Yay.
I actually get to teach you guys something new.
How?
Oh, I think we had a question like this on the homework.
Pre-cal, it's like everything I do, I have to baby step them through it right now. And, and you guys, I'm like, oh yes, okay, I don't really have to teach. I can just graph it, do this, Okay. Slopes of curves on a graphing calculator. Okay. Use the graphing calculator to approximate the slope of the graph of f of x equals 1 over x at the point 4, 1/4. So, and it was the same problem we just did on the previous example.
Okay. Let's see. I thought you guys just pulled that out somewhere.
Jacob's like, oh, what did I miss?
Okay.
I didn't zone out that long, did I?
I'm here now.
Okay. It's like and I don't know that I really pointed it out. It's like on the front page. We had just found the derivative, and then it just so happened to use the same equation.
I was thinking that.
Okay. Are you good then?
Yeah.
Yeah, I definitely know that's a big one to leave you hanging on.
Kind of minor thing.
Yeah, that's our, yeah. It was y equals 1 over x. We found the derivative to be negative 1 over x squared. Oh, hey, same equation, 1 over x. So we use negative 1 over x squared. Okay. He's sitting back there thinking, man, how long did I zone out on that one?
I didn't think I did. That was the thing.
Yeah, I don't know that I think I just assumed, okay, everyone sees it's the same thing again. So, okay. Use the graphing calculator to approximate the slope. What's another word for slope in calculus?
Derivative.
Derivative. Okay. So, they give us a function. F of x equals 1 over x. And they give us a point, yes? And in a point, we know that that is an xy ordered pair, right? So, your calculator can do derivatives if you have a given x value. Now, so what I'm saying here, okay, Can your calculator say the derivative of 1 over x is negative 1 over x squared? No. It cannot just come up with a derivative formula. But given an equation and an x value, your calculator won't even tell you what the derivative is, but it'll tell you what the value is at that point. Okay? So, I was graphing this morning. Let me get out of what all else I've been doing. 2 ways to find it. There's an alpha shortcut here in a moment, but math number 8. Math number 8 says, inderiv. Are you guys where I am? Hit inderiv.
Oh, it does the thing.
Okay, so it automatically now. Are we all? Did everyone's populate similar? Kaylee, Ethan, yours looks like mine. Ross. Okay, so some of the older, I think it's more like the 83. Some of these really older style calculators don't populate like this, and it's a little more complicated. But okay, so dx. This is just talking about what variable are we using, what variable are we taking the derivative with respect to. So if I'm going to use x in my equation, I'm going to put an x there for dx. In this parenthesis goes your function, your equation. What is my function, my given function here? The original function is 1 over x. You can do 1 divided by x. You can do a fraction bar in there. At what point do we want to know the slope? When x equals 4. And it gave us negative 0.0625000039. Now, for checking's sake, we actually found the equation for the derivative of this, right? The equation for the derivative was negative 1 over x squared. So if you do negative 1 divided by 4 squared, do we get an approximate answer that's the same? But this saves us from actually finding the derivative is what happened. Okay? So if you know the original function and an x value, you can find the derivative at the given x value. Okay, notice it's not telling me what equation it used, but it will give me the value. Okay? This is also in your alpha F2 menu up top. You guys know what I mean there? Alpha F2 inderiv is number 3. If you're an alpha type person. Okay, so we used math menu, option 8. I don't know how many details you need to write down about what, we just did there. It was D blank of an equation blank such that x equals blank, right? So we filled in d dx, we filled in 1 over x, and we filled in x equals 4. And we got the approximate answer of negative 0.0625. Okay. Use a graphing calculator to approximate the slope of the graph of f of x equals sine x at the point pi, 0. We're trying to approximate the what? It says slope, so we're going to find the derivative. And this is really good because we don't know the derivative of sine x, do we? And that whole using the derivative of definition of derivative, that's not going to help. So we are provided f of x equals sine x. What's our x value going to be? pi. So d dx of sine x such that x equals pi. So I'll do my alpha F2 menu and go to number 3 this time. Dx sine x. I think you have to end that parenthesis after the x. And I would encourage you to use pi, not 3.14. Are we getting the same answers?
So do you leave it like that or round it up to negative?
Round it to -1. Did we all get the same answer? So that means all of our calculators are already in radians? Is that what you're telling me? Okay. Because if you were in degrees right now, your answer would be different. Because this used a trig function. Because it used sine x, your calculator has to be in radians. Now, of course, if we had put 180 instead in, it would have worked out, but. Okay, so this is approximately negative 0. I think 6/9. I don't know. I'm just writing this out. So no one says, wait, my calculator didn't give me -1. No, it didn't, but it is approximately -1. So we do want to make sure our mode is radians. Okay. Got it? Okay. So you got definition of derivative and a cool calculator thing with it.